All right, my students. So, like we said, we're looking at chapter 3, which is stoichiometry. I want to quickly give you the things and the procedure that you're going to follow when you do a question in the exam. So, this topic is very different from other topics where you're going to get theory questions and whatever. No. In here, you're going to get a situation and they're going to ask you to find the number of moles. So, I need to quickly address that. How you're going to find number of moles in the exam, the different types of questions you can get, and how you're going to follow it. So, here's what I want you to know. First of all, before I tell you the steps that you're going to follow, I need you to know the formulas that we have for finding number of moles. Let me tell you what number of moles are. Moles are a unit that we use in chemistry and other sciences to measure things that we cannot see. So things that we cannot see are there. As long as you're doing something that you cannot see, whether you're doing atoms or whatever you're doing that you can't see, ions, whatever, things that you can't see, then these things are going to exist in large quantities. The quantities will be so large that the things that we are used to, the words we are used to, don't work anymore. We cannot use the word million. Millions, this is way too small. We have millions of people, billions of people. But we have more than this when we are talking about atoms, because each person has millions. So now if we look at that, that means that when we are talking about this level, okay, each person has millions of cells, which means they have even more atoms, because atoms are smaller than that. So when we are dealing with atoms, we are dealing with things that cannot be seen with your eye. You can't even see inside an atom with a microscope. You can see inside a cell. A cell is bigger than an atom. Cells are made up of atoms. Atoms are the smallest thing ever. And these things, we cannot use these words. So because we can't use these words, we have generated a new word called mole. So mole is basically a unit of measure for chemistry and physics, where we are doing things that cannot be seen with eyes. Okay? Things that are there in such large quantities. I just want you to put this in your head that when you see the word mole, we are not talking about a small amount. We're talking about a crazy big amount. Now, moles, just like for any other number, you can have 0.4 moles, you can have 20 moles, although this is too large. Once you see yourself getting 20 moles, ask yourself why, because that's way too big. 0.4 moles is very large itself. It's more than quadrillion. It's more than zillion. It's more than quintillion. Whatever number you can think of, any illions, it's way beyond that. And this is where chemistry starts. You must know what 1 mole represents. 1 mole, remember, this is a unit of measure that we use when we are dealing with things that are large in quantity. Very large. 1 mole is, you need to know this, 2.03 times 10 to the power 23 things. This is called Avogadro's constant. So this is where your chemistry begins, in you knowing Avogadro's constant, okay? Everybody should know Avogadro's constant. What is Avogadro's constant? The number of moles in the number of things in 1 mole. So if you ask, let me just say something. If you check Avogadro's constant, you must see the amount of things, 6.02, sorry, not 2 points, but 6.02 times 10 to the power 23. This tells you how many things. So if I say to you, although it's impossible, if I say you have 1 mole of cats, it means you have 6.02 times 10 to the power 23 cats. If I say you have 1 mole of dogs, means you have 6.02 times 10 to the power 23. And if I ask you, is this possible? You tell me, no, it's not possible. Why? Because things that you can see with your eyes cannot be in the amount. You see, if you have 6 billion, it's like this. If I put it the same as moles, it'll be 6.02 times 10 to the power of 9. This is about 6 billion, 10 to the 9. This is the largest that you guys talk about. But look at this. This is 23 zeros. 9 zeros is billions. But here this is going to have 23 digits after 6. So you put 6, then you put 23 other digits. That's only one mole. That's only 1 mole. So moles are very big. They represent big quantities. Now, what you must know is you must know the ways of finding moles. How can we find the number of moles when we are dealing with chemistry, we are dealing with reactions? How can you find number of moles? So I'm going to give you the formulas right now. Then we can look at the next thing in the next video. Number of moles, when you want to find number of moles, you must know the following formulas. Number of moles is mass over molar mass. So it could be number of moles is mass over mR, or number of moles is mass over AR. These two are all examples of molar mass. So what it actually is the formula is actually number of moles is mass over molar mass. We're going to talk about this further, but I want you to just know this. I want to over explain. Molar mass is given the symbol AR when you're dealing with something that is appearing alone. For example, you have sodium. They ask you for number of moles in a certain amount of sodium. Sodium appears alone, so its molar mass is AR. But if you're dealing with something like oxygen where it's O2 or water where it's H2O, these things are not appearing alone. So molar mass is actually MR. So when do we use MR? When we are dealing with molar mass for things that don't appear alone, things that appear in pairs or more than that. This is when we're going to use this. But it's the same formula. This is mass over molar mass. This is also mass over molar mass. This is the first formula. So when you're doing a question, you're going to write this as one of your formulas. The other formula is going to be what you put when you go to look for a job. Number of moles is CV, which means concentration times volume. So this number of moles, this is concentration, then this is volume. Now where this is tricky is that your volume should always be in dm cubed. Concentration is always in moles per dm cubed, but volume is not always in dm cubed. Volume, let me see if you can still hear me. Volume is not always in dm cubed. So I can see that something is stuck. Volume is not always in dm cubed, so you're going to have to change it to dm cubed. How do you change it to dm cubed? That's an important one. You must know that volume in dm cubed is equal to volume in cm cubed divided by 1000. Divided by 1000. So we're going to make sure that volume, you always change it to dm cubed. Then now you can be able to use this formula. As long as you don't have this, then you can't use this formula. Then now we look at the third and final thing. Then I'm going to look at the next thing in the next video. You should know that at RTP, as long as you're dealing with at RTP, to get the number of moles, you should know that at RTP, 1 mole of any gas has 24 dm cubed volume. So what we say is that we say at RTP, number of moles is going to be volume in dm cubed divided by 24 dm cubed. Or you can say number of moles is equal to volume in cm cubed, but you divide it now by 24,000 cm cubed. Well, maybe I don't want you to get used to this. I want you to get used to volume in dm cubed divided by 24 dm cubed. This is at RTP. So this is the third situation. As long as you are told that you are at RTP, then this is what you're going to use and you are done. So can you make sure you know these three methods of finding the number of moles? Then we're going to look at this other situations in the next video. So the first thing that I've taught you is the 3 ways in which you find number of moles. The 3 ways in which you find number of moles. We're going to talk more and see what you do and the steps that you follow, but we're going to do it in the next video. I'm going to end this one here. Goodbye.